goal of this short video is to talk about pH. pH is probably something we've all heard about at some point, but it's possible we've never really understood the significance of it. The straightforward definition of pH is the measurement of the hydrogen ion concentration. It is a measurement that is reflecting the ratio of the amount of hydrogen ions within solution, which is the hydrogen ion concentration. It's nothing more than that. pH is significant because if it gets out of whack, out of its acceptable range, it can cause problems in the body. One thing I want to be clear is the acceptable range is highly variable depending on the part of the body we're speaking of. So we'll look into that as we move forward in this video. Okay, so the first thing to talk about is the pH scale. And the pH scale can be confusing to some, so we'll try to simplify this as much as possible. The scale runs from 0 to 14. 7 is neutral because that's smack dab in the middle here. Anything below 0 and 7 is what we refer to as acidic. Anything between 7 and 14 is what we refer to as alkaline or basic. The smaller the number, the more acidic it is. So a pH of 1 is much more acidic than a pH of 3. As a matter of fact, it's 100 times more acidic. To say pH is decreasing is suggesting that the hydrogen ion concentration is increasing. A decrease in pH is an increase in the hydrogen ion concentration. An increase in pH is a decrease in the hydrogen ion concentration. That can take a while to wrap one's head around, but the smaller the number of pH, the greater the hydrogen ion concentration. Now, what should our body pH be? It really depends on the region. If we're talking about our blood plasma and extracellular fluid, which certainly makes up a good portion of our body, the pH of the blood plasma is somewhere between 7.38 and 7.42, which is slightly basic. It's just on the right side of 7 here. Now, it has been suggested that that's a very small range for body pH, but it's not as small as one would think because this pH scale is what's referred to as a logarithmic scale. So 7.38 to 7.42 on a logarithmic scale is not really that small. It's certainly narrow, it's not huge, but it's not as minuscule as one might think. And to add to that, there's certain areas of the body that are extremely acidic and other areas that are basic. So for example, the gastric juices of the stomach have a pH of around 1. Keep in mind, battery acid is around 0. So gastric juices are very acidic. As a matter of fact, if you were to pour gastric juices on your skin, it would burn your skin. Certainly our stomach has mechanisms and structures and secretions in it that protect the lining of the stomach from its own secretions. But if we're talking about pH of the body, it depends on the region we're talking about. Juices secreted from the pancreas are very basic. So it would be wrong to say that body pH is 7.4 because we're not specifying what area of the body we're talking about. Okay, so why do we use the pH scale? The quick short answer to that is because it's much easier than using the milliequivalents per liter that we use to describe other ions. So if we look at this, as we've talked about in the past, the concentration of the sodium ion is 142 milliequivalents per liter. The concentration of the hydrogen ion, that is to say, at 7.4 roughly, is 0.00004 milliequivalents per liter. That's not an easy number to deal with. It's not an easy number to say. It takes a while to say. And it's more simplistic if we convert this to a logarithmic scale, which is exactly what pH is. Keep in mind, that 0.00004 is a much, much smaller number than 142. As a matter of fact, the sodium ion has a concentration that is 3.5 million times more concentrated than the hydrogen ion. So let's just compare a couple of pHs here. The pH of 3 is 10 times more acidic than a pH of 4. It's just not a little bit more acidic, it's 10 times more acidic. And this is what I'm talking about or referring to when I mention the logarithmic scale. And the reason why 7.38 to 7.42, the acceptable range of blood plasma pH, is not as narrow as it might look. A pH of 3 is 1,000 times more acidic than a pH of 6. So why do we care about pH? Because pH can denature proteins. And denaturing proteins is causing proteins to unfold and lose their function. Form matches function when we're talking about proteins in the body. And hydrogen ions can disrupt the hydrogen bonding and disulfide bonding that helps create the tertiary structure of proteins. If proteins lose their shape, if proteins denature, they are no longer going to function as they are supposed to. And that's problematic because so many things in our body are composed of proteins. Antibodies are composed of proteins, enzymes, receptors, channels, which we've already talked about fairly significantly in previous videos, signaling molecules. A lot of signaling molecules are composed of proteins. And one thing I don't have up here, our muscles are composed of proteins. So it's paramount that we control, our body maintains an appropriate pH. And in subsequent videos, we're going to talk about mechanisms the body has to help regulate and maintain body pH.